Hello, welcome back to Statistics with Dr. Platt, episode 6.5, where we're going to continue talking about our measures of center, spread, and position. At the endish of last discussion, we talked about the empirical rule, or the relationship between the number of standard deviations we are from the mean and the amount of data that fits in that area. So if our mean is the center of our normal curve, one standard deviation gives us this blue region with a pair of 34% in those regions. For 68%, within two standard deviations to the left and right, a total of 4 standard deviations gives us our central 95%, in which the majority of our data is likely to fall, and any data that is outside of that is in some ways considered unusual. If it's beyond our 99.7% region, made up by -3 standard deviations to 3 standard deviations, our data tends to be very unusual. That is not a fixed thing, and another way to describe it would be using our Chebyshev's theorem, where if our k is greater than 1 and is an integer, or is any value greater than 1, 1 minus 1 over k squared gives us the approximate value of our percentage of data that falls within that number of standard deviations from our mean. This can be done with data that is not as normal as we would like. Another way that we can quickly figure out an approximate for a standard deviation, be it ever so rough, is that our standard deviation can be considered as range divided by 4. So 1/4 of the range of our data is approximately a standard deviation. That would give us the central half of our data, or central half of our range would contain the bulk of our data. When you're comparing two quantities that have different means and similar standard deviations, or different means and different standard deviations, or similar means and very different standard deviations, we can use the tool of the coefficient of variation, which is standard deviation divided by the mean times 100%, to figure out how variable the two different data sets are. A position on the graph of our normal curve can be given to us by the z-score, or the standard score, which we're going to talk much more about when we talk about types of distributions in a little bit. But it is our value minus our mean divided by the appropriate standard deviation that corresponds to that mean. It can be either a population or a sample. The formula is basically the same. Z equals data value minus the mean, be it x bar or mu, over S or sigma, respectively, or as appropriate. Our data is often presented where the values are known and regularly spaced, and each individual value is counted. We can also have data that is weighted, so that some value is a certain percentage of the total score, and another value is a different percentage, and so on, which can be found using weight of item 1 times the score on item 1, plus weight on item 2 times the score on item 2, and so on, and weight 1 plus weight on item 2 plus weight on item 3, all the way up to weight on our nth item. And that will give you your weighted score. This is used by teachers to figure out your average. So let me try to do that. So we have 85 or 84 in a category that is 0.25, a 76 in a category that is 30%, 98 in a category that is 15%, and a 65 in a category that is 30%, and this should add up to 1. So if we multiply L times M, this will give us the number of points out of 100 that was earned in each of these categories, and equals the sum of these values, which when we divide by 1 still gives us a 78. So that is the weighted mean. So this is the weight, and this is the score, and this is the weighted score. The grouped data is essentially processed in the same way as weighted data, where we would take our frequency, which is how many of those occur, and use our class width. So the class width is treated as or the class midpoint is treated as the score, and our frequency is counted as the weight. So if we do the equals D3 times G3, that gives us a weighted contribution of our first class. And each class's weighted contribution is stated here, equals sum of these values equals 662 divided by 32 gives us our group mean. So now we have we can use some tools to figure out our sample standard deviation of grouped data. And we have a few slightly easier to compute by hand formulas. Another way we can look at our data is to break it into equal-sized chunks, or chunks that contain an equal number of elements. And the key measure of center in that regard is our median. So if we have our 32 data values, our median is the central value of a sorted and organized set of data. You need to make sure the data is running in a way that is easy to tell what is the lowest, and the data progresses upwards. So in this case, we have 32 values. 32 divided by 2 doesn't give us an exact middle point, but we have our 16th value, 16 up from the bottom, and our 17th value, 16 down from the top, are 21 and 20. Halfway between them, our median is 20.5 equals median of our data is 20.5. And our median can be accompanied by 4 other values. Our minimum value, our minimum value, our maximum values, and 2 values that split the lower half and the upper class of our data set in respective halves. Those are our quartiles. And we will come back to those in our next segment.